Hi everyone, this video is about demonstrating a project network intrusion detection system. So firstly, we need to download the dataset. So after downloading the dataset, we need to extract the CSV file. So we have extracted the dataset from Kaggle. So after extracting the file, you can observe here. So we can get here two types of datasets. One is test data and another one is the train data. So this we will be getting after extracting. So after this, so we are using here Google Colab. So in Google Colab, we need to import the data sets that we are using here. So there are two types of data sets that we are using here. So first one is the test data and another one is the train data. So we are importing both the data sets in the Google Drive. So after importing, we need to copy the path of the test data and the train data path. So after copying the path, we need to paste here. So this is the Google Colab data drives path. So this is the import files that we have imported here. So NumPy, Pandas, Seaborn, Matplotlib, Pandas, and we are using here sklearns and we are using here LightGBM, then Tablet, XGBoost. So these all are the imported files we can see here. So this is the thing that we have imported, and this is the path that we have derived. So next will be continued by our teammate.
Yeah, hi everyone. Here train.head. Train.head is a Python pandas method used to display the first few rows of data frame name in train. This is commonly used for a quick overview of dataset structure and content. This is the overview of our few dataset rows. Next train.info. Here train.info explain about display information about the data frame including data types and non-null values. Here non-null values and data types are displayed. Next, describes provide summary statistics for numerical columns. These are the summary statistics. Next, describe it describes objects columns. These are the objects columns. Shape it returns the number of rows and columns in the data frame. These are the number of rows. Next, Null.sum it counts the missing values in each column. Next, this count plots. It's explain about the create a count plot for the class variable using Seaborn. It next this prints explain about the printing the description of the class in the class variable. Here we define the LE. LE is the label encounter. Next it display the first few rows of the modified train data frame. It's in separated features in X train and Y train in the data frame. Next will be continued by our teammate.
Here we are using random forest classifier, which is used for regression purpose. As shown here, the following code snippet we are using, it is used in order to initialize a random forest classifier that assigns into a variable RFC. Here in the second line, the second following line, here with the goal of selecting top 10 features, and the next following lines, the line fits the RFE model to the training data X-train feature variables and Y-train into a target variables. Then the feature map is equal to I of v, I comma v for v comma I. This line creates a list of tuples that is where each tuple contains a boolean indicating whether it is true or not true, that is false. The following line selected features. Finally, this variable holds the list of feature names that were selected by the RFE process and are deemed as important for the model. Next here, the X-train is equal to X-train of selected features. This line updates the training data to include only the features that were selected by the recursive feature elimination RFE process stored in the selected features variable. This code snippet standardizes the numerical features in both the training data X-train and the test database test using the standard scalar. It transforms the data to have a mean of 0 and a standard deviation of 1, making the features comparable and suitable for certain machine learning algorithms that are sensitive to the scale of input features. Here, the X-train, X-test, Y-train, Y-test is equal to train test placed. This
where the hyperparameters obtained from the best trial during the optimization process using Optuna, where the trains the decision tree classifier using the training data X-train and corresponding Y-train. It calculates the accuracy of the X-train and the train score to the X test and the Y test score, to where it will be stored in the decision tree train and the test. It will be printed as a the result of the score result of the train and test will be printed. This line creates the 2D list data containing the model name KNN, KNN train and the KNN test, where in this also logistic regression LG train and the LG test. And here decision tree DT train and the DT test. Column name here, it will define a list of column names containing the column names for the table specifying the header of model, train score and the test score. Here print in this it uses the tabulate function to formulate and print the table. The data argument in the 2D list containing the model information header provided. This is the table of this, and next will be continued by our teammate Spurti NM.
So the following code snippet explains about the three keywords. First one is about the seed, next is KNN, and next is LR. So seed is nothing but this is often used to set a seed for a random number generation, ensuring a reproducibility in the machine learning experiments. So next is about the KNN. KNN is nothing but it is a K-neighbor classifiers. So here an instance of the K-neighbors classifier class is created. So K-nearest neighbors is a classification algorithm that assigns a data point to the majority class of its K-nearest neighbors. So next is about the LR, that is a logistic regression. So logistic regression model is a linear model for a binary classification that uses the logistic function to the model probability of a certain class. So next we are going to see about models. The following code snippet going to explains about the models. So models is a nothing but it going to creates an empty dictionary. So empty dictionary is only called as the models to store a different classifiers. So it going to create a different models of the KNN, LR and the decision tree classifier. So next we're going to see about the scores. So the scores initializes an empty dictionary called a scores. It's going to store an evaluation process. So the outer loop for name in models iterates over the models. It's going to iterate over the models, and this course name is going to explains a nested dictionary. So next we're going to see about the code snippet, that is a defined line name. So this defines a function line name. So define going to explains about the function line name and prints out the model validation information. So next is about we're going to see about a for name in models. So it's going to iterates over the models. So as I told you before, the models is used for storing the empty dictionaries. So next is about for scorer. In we come across a precision and another one is the recall. So it's going to iterates over the scoring metrics, which are the precision and recall. You can see here, so mean, print and precision recall are the keywords that we come across. So mean is nothing but a standard deviation of the scores for the current model and the scorer. So next is STDEV, standard deviation. So STDEV is nothing but it is a standard deviation. And next is a print statement. So you can just see the mean and precision and mean recall for the K-neighbors classifier and model validation. So this main following code going to explain about the mean precision and the mean recall about the different algorithms that we have used over here. So first one is the KNN, logistic regression and decision tree. So you can just see the precision and recall of the each models here. So next is about the visualization. So from this visualization we can observe which algorithm have a better scores here. So decision tree classifier has a better scores as we compare between the K-neighbors classifier and logistic regression. So again we are using a models here. Models is nothing but it is an empty dictionary which going to stores the three types of the algorithms, that is K-neighbors classifier, logistic regression and decision tree classifier. So next is about the checking about the then is this following code snippet going to explain about the accuracy, then weighted average, macro deviation, and anomaly. So how much the project going to know, our project going to explain either the data set which we have stored has a normal appearance or an anomaly appearance. So by seeing all this features, that is precision, recall, F1 score, support, we can come to know either the given data set is a normal and or the anomaly. So this is the visualization that we have done. So we are using the three algorithms that we have used here. First one is k-neighbors classifier, logistic regression, and decision tree classifier. So we can just observe here. So decision tree classifier having the major F1 score, rather comparing between the logistic regression and k-neighbors classifier. So this going to suggest that decision tree classifier suits a project in a well manner, and it brings a better outcomes. So saying this, thank you.